In continuation of HTTP topic, today we're looking at HTTP headers. How headers helping HTTP protocol to deliver the content, and also we'll be looking at different security mechanisms that protocol is using in order to prevent different cybersecurity attacks and make our experience on the internet more secure. In the last video, we have looked at basic structure at how HTTP request and response works. This is the browser, this is basically the user, us, and this is the web server. Right? Browser and server. And they communicate with each other using the requests to the server and the responses from the server. So when browser requests something from the server, it requests using request line and HTTP headers. And server responds to the browser in status line, stating whether the request was successful or maybe for informational purposes something relevant is added to the status line. And HTTP headers, and finally the content. The browser, the user only sees the content, human readable sort of. I'm not saying that HTTP headers are not human readable, no, but unless we inspect the page, unless we use the developer tools of the browser, we usually don't see the HTTP headers because we're not that concerned about them. It's the content part that we're looking for. However, those who are watching this video at the moment, I know that you want to delve deeper and understand how this protocol works. So just saying that you see the content wouldn't work for you and you want more information on this topic. Maybe you're in the networking field, maybe you're IT professional, or maybe you just want to learn about HTTP more. Refer to my previous video, HTTP part 1, to understand how, in more specifics, how this structure works, and in more detail how HTTP protocol creates the connection and passes the information. Here we will not be covering it as in detail as it was covered in previous video. So, HTTP headers. You can see that this is the common part of both request and response. And these headers carry the metadata, the key information about request and response. At the moment on the screen, you should see the recording of how, using the developer tools of the browser, you can see the request headers and response headers. These headers are usually presented in a specific syntax. It is the name and the value. The syntax can be different. It can be name value, name parameter, equals value, and etc. Looking at different syntax options, you can see name, for example, the name of the header, user agent, MacBook. So user agent is a header that contains information about our physical machine, about our browser as well, actually, to connect to the internet and connect to the web server. So user agent can be Mozilla browser and MacBook. Depending on the resolution, you can also get more information about the computers that user is using. It can be name, parameter, value. So for example, you can set a cookie header to something, or it can be name, value, value. If we want to list different values for single header, it's also possible. Or it can be name, type, subtype. Type/subtype. The most common use case of type/subtype is the type of the content that we have on the page. So if it's an HTML page, it can be HTML type and the subtype of it. It gives browser, we usually as users, we don't care about it much. However, it gives our browser the idea of what content they're receiving so that they can use relevant tools in order to show us this content. Because content types can be different. And some browsers might not be able to show us the content that the page is encoded in. It happens very rarely, but it does. So it's very useful for the browser to see what content they should expect. You might ask, are all headers hard-coded? So we have certain header names, right, and values for them. Can't we come up with our own headers? The answer is yes, we can. So if you add the X and dash prefix to the header name, custom header name, you can come up with your own header name. So for example, X-Jama. I came up with my custom header on my website. And this header says yes if the user is accesses maybe from certain geolocation. This header is added. For example, for users who are accessing from US, the header will state X-Jama yes or X-Jama no, and etc. So you can come up with your custom headers in order to have better statistics of your web page. So for example, you can classify the requests and responses based on the header values. So those header values that are ex Jama, yes, you take them into one side, and then the ones that have no, you take to the other side. This method of coming up with custom headers officially has been deprecated, because there have been some custom headers that became official headers with X prefix, and they're no longer custom, they're official. That's why, in order to differentiate between custom and headers that are official, X-custom headers have been deprecated. However, I was doing some checks before recording this video, and many browsers, many protocols are still using X- as custom headers. Although, like, officially in RFC papers, it has been deprecated. Headers can be manipulated if the protocol that you're using is not secure. If it's HTTP, for example, and not HTTPS, the bad actors can manipulate values of your headers. For example, they can change the user agent so that you don't know exactly what browser certain things were accessed from. Or they can change any other value of the header if they can, again, if the protocol and the connection is not secure enough. There are 4 types of headers: response headers, request headers, representation headers, and payload headers. Well, the header types, the headers that we have, belonging of these headers is really intertwined. So if we say some headers are request headers, you can also see them in response as well. And similarly, if the headers are payload headers, you might be able to see them in... There has been quite a mixed belongingness of the headers to different subtypes. However, I have listed some headers that are most commonly request headers or most commonly response headers. And next we will review other 2 header categories, which are the representation and payload. Request headers, examples. It can be accept something, for example, accept language header. I just put asterisk because there are different accept headers. Please look at the screen at the moment and you can see different types of them, even in a simple request that you're making. It can be accept language, accept char set, which is the character set. For example, in our request, we're sending the language that we would like to see the page in. Have you ever wondered that when you go to another country and you open an international website, you can see that the website is being loaded in the local language, local international language, instead of, for example, English. Also, you were like, but this page has an English page. Why don't I see that page? It's because based on your geolocation, the accepted language can change. The language that you're requesting the page in, and it can be not English but German, let's say. Access control headers. There are a couple of headers that come under access control. That's why I have the asterisk here. What access control headers mean? Actually, it's a topic as so big that it can be covered in a different video, and it probably will be covered in a different video. However, at the moment, let's accept control headers is the part of course. Cross-origin requests. Cross-origin requests is technique when we are using the information of the other origin of the other website, let's say, on our website. A very good example of it is how, for example, on property websites, we can see the map. You can see different estates on the map. And the maps are not provided by the website. Rightmove.co.uk, for example, it's a very famous property website in the UK. And when you see the properties on the map, you can see that if you look at the developer tools, you can see that the map is provided by Google Maps, or it can be provided by other maps provider. And it's referring to the maps of Google Maps in order to provide interactive experience for users and shows the estates on the map. In which case, the headers, in the request headers, we can set if we would like to see the information that is coming from the other website or not. If in access control headers we said that we don't want to see information from other website, some of the elements of the website that are coming from other origins, other web servers, will be blocked. For example, if you're blocking this, you might not be able to see maps on this rightmove.co.uk. The use case for this one, why do we need it? Well, first of all, for security. Sometimes we can access the website and website has embedded video in it, or embedded map, or the image link even. And this is from the website that is not secure. First of all, maybe HTTP website, it's not using an HTTPS. You can click on it, or you can start watching video, and it can result into some malware, into getting your browser infected or getting your machine infected. And this is the main use case for course. And it's a very big topic that we'll be covering in another video. However, if you want to nail the interview related to networking, related to web applications, you better explore this topic in more detail. So access control headers and course allows us to enrich our website with different elements that make it better, that make it more interactive, so that we don't have to reinvent the wheel. As with property websites, they don't have to, all of them don't have to come up with a new map version of the areas that they're advertising. They can just use Google Maps because Google Maps has already done it, or it can be Apple Maps and etc. Another important request header is cookie. I'm sure you all heard about cookies already. And cookie request header, whenever we're visiting the website, in our cache we might have the cookie associated with the website. And with that, we send the cookie in our request saying that I have this cookie in my cache. Can you please check it? And what can cookie contain? Cookie is nothing but your personalized preferences collected by the website. And they are usually stored in your browser cache. When you send the cookie to the web server, you let the web server know that you would like certain personalizations that you have set previously. Example, you go to google.com and you set the dark theme so that it's not white, it's on the dark background. You set a certain language, and all of these preferences are coded to a cookie. Whenever you access Google again, in your request you send that cookie saying that I want this personalization. And then when your Google page loads, you already see Google in dark theme. Also, the default Google page is not in dark theme, it's in a light mode actually. But thanks to that cookie, it loads in a way that you expect it to load. Happened to me many times. And if you start actually checking it, for example, when you log into a certain website, you can see that you're logged in. So your session is still valid, right? Your authorization session is still valid. You don't have to log in all the time. Meaning that you have a cookie that says that this user has already logged in and you don't have to log in again. Similar for authorization cookie, it helps in your request. It helps you to prove sort of that you're authorized user and you can access that resource, that web page, for example. User agent, we already discussed that. It contains different information about our browser. It can be a resolution. It can be the physical machine that we're working on, Mac, for example. And usually it's important for those who design our websites because they know what resolutions might not be working, what resolutions are not showing perfectly well. Usually people don't care about this, but user agent information is usually collected by web servers in order to analyze which browsers users use most and etc. When you see on the internet the statistics, Google Chrome is the most used browser. How do you think they know that? How do you think they realize that it's most used browser? Because the fact that it has been downloaded certain times doesn't mean that it has been in use certain times. So this user agent header is the statistics that they're collecting in order to understand which browser is most popular. Next, we have response headers. Response headers come with the response, obviously, as a package that the server is sending to the browser in user's request. Response headers can have common header names with request headers. However, there are some that are very specific to response. Some of them are content, the headers that start with content dash. It can be content length, content encoding, content range. Content length is the length of the content of the page, basically. The encoding is the encoding type used on the page. There are several encoding types. You can research it in your time, encoding. And there is range. So sometimes when you Google for something, Google gives you the part of the page that contains the answer you're looking for. And when you access that page, you can be taken to that specific range, to that specific character range that you're looking for. Or at some point you stopped looking, you stopped browsing through the page at certain point, and the web browser has memorized it, and now it's sending the specific content range header header saying that the user should start looking from this point because that's where they stopped previously. Set cookie. So you remember how we discussed cookie? Now, if a request that is received by the web browser doesn't contain a cookie, so the user is accessing website for the first time, or probably user purged their cache before accessing the website. That's why there is no cookie. Browser sets cookie, saying that, okay, I'm setting you a new cookie so that whatever you use, whatever personalization you use will be recorded in that cookie, and then you can send it back to me whenever you access my website again. And that's how this whole shebang starts. Another example of response headers is digest. Digest is the cryptographic algorithm that is used to encrypt the page. And there are a few really. So digest shows the type of the algorithm that you are using. Example can be MD5, for example, MD5. SHA, it can be one of the SHA cryptographic algorithms, depending on the web browser. So far, we have reviewed request headers and response headers. There are two more header categories that we need to look at. It's representation headers and payload headers. As I said, these categories are not hard-coded. Some of the headers that you can see can be in both representation header category or the request and response header category. This is not hard-coded and this is not strict per se. These categories are just created for you to better understand what headers are we talking about, to classify them better. The examples of representation headers are content encoding. We have reviewed those. They are included in response as well. Content type, the type of the content that we're expecting to get, and transfer encoding. This is the encoding of when the package is transferred. This is the encoding type that is used to transfer the content. You know, whenever the server sends the response to the user, it has the content with it, and that content can be encoded. And the transfer encoding, it can be zipped, for example, compressed, so that it has less size. And the encoding, compression encoding type that we're using can be different. It can be bzip, it can be zip, it can be jzip, depending on the compression algorithms that we're using. And in order to decompress the page when the user receives it, browser needs to know what algorithm for compression has been used. And that's where we store the transfer encoding. Browser might not be able to decompress it in very rare cases, so that when it's not, you can at least looking at logs understand why it happens. It means that certain compression algorithm has been used that is not supported by the browser. That's why they always say update your browsers, keep them fresh, keep them on the latest available version, because the compression algorithms can change, and by updating your browser you make sure that your browser is up to date with decompression mechanisms in order to decompress the content and do many things as per state of things now, the latest version of it. Payload headers, usually the example of them are content range and content length. You can see that there is quite an overlap with what we have seen in the response headers. Some headers can be used interchangeably between response and request headers. It's cache control, so both browser or server can set limits on cache. So whether we accept the cache, whether we don't want cache at all, right? So according to GDPR, many websites now ask you if you want some cookies to be collected or not. You can reject it. So saying that you don't want any cookies to be collected. And this is usually reflected in the headers, in the cache control header, meaning that we don't want any cache at all. Or if we want the cache, we want it to be fresh. So we want to set certain time to leave, TTL, on the cache in seconds usually, that the cache will be valid for. It can be 24 hours, it can be a week, and etc. Of course, you have to set it in seconds. Second header is keep alive. Keep alive header sets timeout until which we will be waiting for a web page to respond before we timeout it. And although it can be set on a firewall, it can also be set in the headers as well. And whichever is shorter will usually win. So if firewall has shorter time to leave, shorter keep alives, then the timeout will happen faster. However, if there is no firewall involved, keep alive values set in headers can be taken into account. And there is one last connection header. There is more information about the headers provided on the internet that you can read through and delve into it, because it's a very interesting topic realistically. I welcome you to go on the internet and do more research on different header types. Now let's talk about the security in HTTP. As I said, the HTTP itself is not the safest version of the protocol, of the same protocol, and usually many companies, websites and even browsers are using HTTPS. You must have heard about it. HTTPS, in the beginning of the website at the URL tab, if you see HTTPS or if you see the icon of the lock, it means that your browser is using HTTPS to establish that connection, and it means that the connection is secure. So HTTPS is using port 443 instead of 80. Port 80 is used by HTTP. It's using TLS encryption protocol. It's running over TLS or SSL. By the way, SSL is a deprecated version, okay? New is TLS. However, sometimes you can hear it's running over TLS, which is technically true because not all sources know that SSL has been deprecated. Realistically, it's using TLS. It's required by some of the data protection laws out there, and we know for sure that HTTPS is required by GDPR, which is used in European Union. It's required by Data Protection Act, which is used in the UK, which you know that after the Brexit, GDPR might not be applicable to the UK. That's why United Kingdom has its own Data Protection Act. It prevents man-in-the-middle attacks. Because if you're using an HTTP, imagine this use case. You're on the website that is running over HTTP, right? And you're using Wireshark to capture some packets. And you enter your credentials, username and password, and you try to access a website. If on the Wireshark you go back and open what you have just captured, you can see in plain text the username and passwords that you've entered. It can be like Jamila and password 12345, and you can literally see it. Whereas with HTTPS, even if you capture packets with Wireshark or any other packet capturing tool, you will not be able to see the credentials because they will not be in human readable format. They will be encrypted, and you can't decrypt it sort of and see the credentials. You just can't do it, and you can't see what has been entered. That's why it's very important to use HTTPS. HTTPS is using asymmetric public key cryptography, meaning that the private key is owned by the web server and the browser is obtaining public key of the web server in order to prove that it has been granted to access that web server. They're using different cryptographic algorithms, and usually using headers, they agree on the cryptographic algorithms that they are going to use. One of the headers that helps in that is digest, for example, what digest is being used. And there are security related headers that also can be utilized in order to agree on that cryptography algorithm. Another protocol or set of rules that can be used by HTTP, by the way, it's becoming more and more common that they use it, is HSTS. HSTS stands for HTTP Strict Transport Security. It's simply a protocol, but not like HTTP. It's protocol of rules for the companies and for browsers, for web servers, set of rules that they agree to follow in order to ensure that the connection is secure and the experience of users on the internet and the web browsers is secure. HSTS has a few rules among many, and we will cover the most important of them. One of the rules of HSTS is that HTTPS is always on, right? We are always using HTTPS to transfer our information. Another one is that we're adding a header to show that we're using this policy. The header is called strict-transport-security, where we can set the max age. Max age is usually by default set to 6 million seconds. However, you can change it. Max age denotes the maximum amount of time that we are going to adhere to this policy. It of course can be updated, and max age is always in seconds. The second one, you remember, so this header has this certain syntax: key, parameter, parameter value max age equals 6 million, and then we have another value of this header, include subdomains, it's called. Include subdomains means that we will be including subdomains of our domain into our adherence to the policy. So it's not only Google.com that is HSTS compliant, but also it's maps.google.com, subdomain of Google, translate.google.com, subdomain of Google, and many others. So it's important to remember that we need to include our subdomains if we want our full website to be protected. HSTS protects against a number of attacks. One of them is downgrade attack. Downgrade attack happens when encryption version of our page is being downgraded to a lower level that can be hacked. So for example, this is just a hypothetical example. We're using the TLS version 2 because TLS version 1 has been deprecated within our HTTPS, right? And the attacker downgrades our TLS version to version 1 because version 1 can be hacked. And when our security is downgraded, we still don't notice that it has been downgraded, the protocol version has been downgraded, and it gets unnoticed by us, but attacker can access our web server or perform a malicious attack after the downgrade. HSTS usually helps to prevent it because it ensures that the latest version of encryption is used in order to prevent downgrade attacks. Another attack that is being prevented is SSL stripping. With SSL stripping, the encryption algorithm is not downgraded. It's removed altogether. We're removing SSL. In this case TLS, because SSL has been deprecated, and we no longer have encryption at all, which makes our website to run on HTTP instead of HTTPS, which is very dangerous because we expose the information of our users that are sending us the information, and we can expose our web server to a number of attacks, and we can put under the security of our users and make it questionable basically. The last attack that it's protecting against is mixed content attack. So we have already covered that the website can embed the content from different sources on it. It can be maps from Google Maps, or it can embed a video from YouTube. On many occasions, when visiting a website, you can see that the website is example.com that you're accessing. However, you can see a video that comes from YouTube because it has the YouTube icon on it. The YouTube video, the video from YouTube, has been embedded in the website. It doesn't mean that the website has downloaded YouTube video and embedded it. It just has the link that embeds that video. So websites usually do use content from different sources, and this makes their life easier. However, this YouTube link that we're using or the source that we're using can run on HTTP. So the source that we're embedding into our website can be not secure. It can use HTTP, it can contain malware, and etc. etc. There are so many different possibilities that can harm our website or that can harm user as you when you're accessing the website with low security. That's why mixed content attack happens when the embedded elements of the website have low security, and HSTS adherence to this policy helps us to prevent that. It helps us to make sure that the content embedded to our website is secure, it's running over secure version of HTTP, and it doesn't have any malware in it. Thank you very much for watching my videos on HTTP, and please don't forget to subscribe to my channel and like this video. It's very important because I am working with another algorithm called YouTube algorithm, and in order for it to do its thing, you have to subscribe and like my channel. Please don't forget to do that. Have a nice day. Bye.